Alright, so the first term, you just change that to sine squared over cos squared, and then those two would cancel each other out, right? Because this is actually cos squared over 1, so they would cancel out. The second term squared, you also change to sine squared over cos squared. Now guys, from here, you could either decide to, because this is technically a compound fraction, right? This is a very simple one. This is a compound fraction, so you could just multiply the top and the bottom by cos squared if you wanted to, okay? Because that would get rid of the cos squared at the bottom. But what I did was I just put them times, all right, because it was just sine squared a over 1 fraction. So I just changed that dividing by sine over cos to multiplying by cos over sine. So then the sines would cancel out, then you're left with sine squared a plus cos squared a, which is 1. Just make sure that if the question is working with a's, you need to obviously keep the a's in your actual calculation. I've often seen that people who are used to working with x's, you'll change it to an x, and then sometimes something gets like confusing or mixed up. And guys, also layout is very important. If your layout is not correct, you lose marks. Okay, so you have to start by saying left-hand side equals, then you are only working with the left-hand side. I don't want to see any equals to 1 on the side here. You get it to 1, and then you write equals to r and check. So that is very important, guys. Are there any questions on this one? No, all right. Right, there we have C, and guys, for some of these, there might have a different way to do them as well. So just let me know if you had a different option that worked. That's fine. So this one on the left, outside side, that is the difference between squares. So I got sine squared x plus cos squared x, which is just 1, and sine squared x minus cos squared x. Now, once I just figured out that that is equal to 1, I was actually just left with sine squared x minus cos squared x. Now guys, here is where you need to actually look at what you're trying to prove. So there is no cos squared x on the right hand side. So essentially you need to get rid of that cos squared x and change it to a 1 minus sine squared x. This step you don't really have to show, it was just me multiplying the negative 1 in there. And then sine squared x plus sine squared x is 2 sine squared x and minus 1. Did anyone do something different for that one at work? No? Right, that's fine. Yeah, then the next one actually was the same as that trinomial example that I wrote down for you guys on Friday. And that wasn't on purpose. It just happened to happen like that. Okay, but no one also asked me about this question on Friday, so I think most of you remember that you have to do that. So the one you have to change the sine squared x plus cos squared x and just write them on either side there so that it is that trinomial. The sine squared x minus cos squared x at the bottom with the difference of 2 squares. And then it was quite simple from there. You just had to cancel out the 1 sine x plus cos x bracket at the top with the sine x plus cos x bracket at the bottom, and then we were left with that you had on the right. If you wanted to start working on the left, right, you could have just multiplied the top and the bottom by sine x plus cos x. That also would have worked, right, if you decided to work on the right instead. So then you just would have had to multiply out and would have gotten sine squared x plus cos squared x, which you would have had to put together as 1. So this would have, worked as well. Any questions on that one? Okay, here we have I. Now guys, in I actually started working on the right. I don't know how many people started working on the left. If you worked on the left, you just would have multiplied the top and the bottom by 1 plus cos x. Yes, fine, that would have worked. I just thought, okay, let me just show you guys an example where we are putting 2 fractions together, because we didn't actually do an example like that on Friday. So guys, if it worked on the left, by just multiplying by 1 plus cos x, you don't have to copy this down, right? Like I said, I just wanted to see an example of actually putting 2 fractions together. So here you have 2 fractions. The LCD is, actually 1 over tan A. And guys, are you remembering that you don't have to do 1 over sine over cos? If it's 1 over tan, you can change that straight to cos over sine, right? So here, you don't have to do, this is what I mean. Show you guys. You don't have to say first But this is 1 over sine A over cos A, right? It is, but you can actually just go straight to cos over sine. Okay, that's actually one of the new, not new, but one of the identities that we wrote down on Friday. So I just did that, and then I saw, okay, they do actually have the same denominator now, so I can just put it together as 1. But then here, I was stuck. All right, now I didn't have anything to do. Now, this is what I mentioned the other day. If you just have 1 term in your denominator and you get stuck, you reach a dead end, you're going to just multiply the top and the bottom by that same thing. Okay, which is what I did here, which we also didn't do an example of on Friday. So I multiplied the top and the bottom by sine A. That's what I got at the top, obviously just sine A multiplied by that. But at the bottom, I got sine squared A, which I then changed to 1 minus cos squared A, which I then factorized, which then allowed me to just cancel out those brackets, and then I got to what was on the left. I think it was shorter if you worked on the left. Is that true? It was shorter if you just did on the left hand side. So if you guys want me to write out that method working from the left, I can do that for you. Yes. Good help. But are there any questions on this, guys? So this is one of those questions again where it would have worked perfectly fine, but from the left or the right. I just wanted to show you guys one was putting some fractions together. Okay, before we look at L, let me just go back to F quickly. There you go. Yes, I know. Okay, L, we're gonna go. There's L. Yes. Yeah. Alright, guys, that is what I did for L. Again, if you did not the first time, but I'm sure all of us would have changed that time to sign of a contract. Then from there, can we pay attention, please, guys? From there, I did my tip and times thing. So I had cos x times cos x is cos squared x over sin x plus just the sin x. Now here I just wrote sin x as sin x over 1 because now I do have two fractions I have to put together as one. Alright, so sin x over 1 and cos squared x over sin x, they don't currently have the same denominator. What would the LCD be of these two denominators, guys? Sin x. So we need to change this one to sin x. Alright, so remember that method is you ask yourself, the current denominator is 1. What if I multiply 1 by to turn it into the LCD, which is sin x? Fine. Then let's do the same thing at the top. Okay, so that is why I wrote that thing on the side. Maybe if you didn't write that in, just do that now as a reminder. Because guys, we learn how to add fractions together like in what, grade 6 or something, right? But then every year it pops up in all these different topics. Right, so now we're doing Trig, but we are still having to add two fractions together by writing them over the LCD. Okay, so you do need to make sure that you actually are okay with that. And also that you can recognize that, right? Because this wasn't a fraction originally, it was just plus sign. So when you see something like that, you need to realize, okay, sin x is the same as sin x over 1. So those are actually two fractions that I'm adding together. Okay, so now sin x times sin x is sin squared x over sin x. So now because they have the same denominator, I just wrote them over 1. And then that's quite nice because cos squared x plus sin squared x is just 1. Okay, which is what we did have on the left. So guys, there were lots more in that exercise, obviously, right? I just chose 5 of them randomly. But if you feel like you need more practice in these, you can do any of those. And the nice thing about these questions is the answer is already kind of there, right? You know what's going to work towards something. So if you are trying to do any of those and you can't get to it, you can definitely ask me, I don't mind. I can help you if you're stuck with anything. But I do have to teach you some new identities today, but then we are going to practice more of these questions with the new ones. Okay. Right, so compound angle identity. You can write that down if you're heading. Okay, guys, now these, the actual four of these, they appear on the formula sheet. Yeah, I'm just going to write them down and then we can talk about them. So, first one. All right, so the first one is cos of this is x and y, cos of x minus y is equal to cos x times cos y plus sin x times sin y. So these are called compound angle identities because if you're just looking at where it's cos and the bracket, in that bracket you have two angles, right? So it's a compound, one angle minus the other. So for example, if we wanted to use this like in, in numbers, if they were asked to for cos of 15 degrees, for example, so now do that thing. That's fine. Right, if they ask me for cos of 15 and they say you have to do this without the use of the calculator, then you have a triangle with a 15-degree angle in it. Remember those facial triangles. What are the angles that we have in those triangles? 45, 30, and 60. Okay, there isn't a triangle with 15 degrees. So what we can then do is we can say, isn't 15 the same as 45 minus 30? Right? What's 45 minus 30? That is 15. Okay, so I am writing 15 as a compound angle of angles that we actually have in our special triangles. All right. This is just an introduction example. We are going to do lots more of them. Okay, so I'm very quick. But now, guys, please remember this is not like a cos is not like a number or variable that you can multiply into a bracket. You can't say, oh, this is cos 45 minus cos 50. Right? That is not the case. And I can prove it just by showing you on the calculator. Let's just see quickly. Cos 15. Let me round it like this. Cos of 45 minus 30, right? Is 0.97. Now I see this all the time, guys. People say, okay, this is not the same as cos 45 minus cos 30. Right? Let's see if we actually get the same answer. Cos 45 minus cos 30. We do not get the same answer. Do you guys see that? All right. So cos is not like a variable on its own that you can just multiply into a bracket. If you are getting something like this, you actually need to use the compound angle identity. Okay, which seems very complicated, but you don't have to know the proof for it. Okay, but you can look the proof up if you want to. So this formula is saying if you have cos of an angle minus another angle, which we have here, you are going to expand that. We call this the expansion. We're going to expand that to cos of the first angle, right? So cos 45 times. What does this formula say? Cos of the second angle. Right, the second angle, if we're looking at this, is x minus y. Minus is almost like separate from the term, right? So the second angle is not negative y. We see it just called y. So we actually are kind of like ignoring that minus. Okay, so the second angle is 30, not negative 30. That's what I'm trying to say. Then the formula is saying plus sine of the first angle, so sine 45 times sine of the second angle times sine of 30. Let's see if we can remember those triangles, guys. Remember for these types of questions, you have to draw your triangles. Okay, so you would draw them on the side. And do we need both triangles for this question? Yes, because I have a 45-degree angle and a 50. Okay, so you need to draw both of them, please. You don't have to draw them as big as me. I'm just doing it now because some of you guys do it. Okay. Alright, so I usually do the 30-degree angle at the bottom and then at the top. Alright, this one is easy to remember if you remember that one has to be opposite 50. Okay, because then you just go like anti-clockwise. You do 1, 2, 3, but the 3 has to be the square root. Okay, let's take that line. So I put my 30-degree at the bottom. I remember that there's one is opposite 50. Like that. There's 1, 2, root 3. Now remember, this is a right angle triangle, right? We all remember that the hypotenuse is supposed to be the longest side, right? So 2 out of these 3 sides, 2 is the longest side. Okay, so the hypotenuse has to be 2, and then that has to be the square root of 2. So the other one, 45 and 45, you have 1, 1, and then root 2. Okay, now we can use these triangles to write these actual values down. So cos 45, you can look at either one of the 45-degree angles. Cos is the basis of our hypotenuse. 1 over root 2. Times cos 30, so now we're looking at the 30-degree angle. Remember cos adjacent of our hypotenuse. So root 3 over 2. Plus sin 45, it's the same as cos 45, right? It's opposite over hypotenuse. So again, 1 over root 2. And then sin 30, we're looking at the 30-degree angle opposite over hypotenuse. So 1 over 2, a half. Now we can add those together, right? Guys, this is a bit easy because if the question is saying without using the calculator, you're supposed to do this without using the calculator as well, right? Now let's just quickly simplify these. And the nice thing here, guys, is that when I multiply these denominators together, I'm going to get 2 root 2 and me as well. Right, so they're all going to have the same denominator from the start. I'm going to write this over 2 lines, so it's not that small. So this is going to be root 3 over 2 root 2. Plus, for the next product here, the numerator times numerator is 1 over denominator times denominator is again 2 root 2. Now you can add those two together, right? Because they have the same denominators already. So we get root 3 plus 1 over 2 root 2. And guys, you're going to leave it like that because as soon as you start fiddling with that, or as soon as you write that as a decimal, they're going to know that you use your calculator. Something that they can say is that you have to write your answer with a rational denominator. Remember that? Rationalizing denominators. A rational denominator is one that doesn't have a third in it. Alright, so let's think, how can I, so they can ask you to do that. Okay? What would you have to do here to get rid of this root 2 at the bottom? Times by root 2, right? The top and the bottom. So I can do that, times by root 2, but again, guys, to prove that you are not using a calculator, you must actually scroll that on the side. Okay, so whenever the question is a no calculator question, we need to write down a lot of steps, basically. A bit of a pain, right? But we need to practice it in class so that we are ready for that. Yes. Yeah, so you don't ask if you can just do it like that. Okay, now guys, here, remember we have 2 terms here, right? So basically I must multiply root 2 by both of them. Now do we remember our third laws? What happens when you multiply root 3 by root 2? It's root 6, hey, they have the same roots. Both of them are square roots, so you are allowed to time them together and write the product of 3 and 2 under that one root. Okay, so this is actually going to be root 6. We did this third laws last year, right at the beginning of the year. And I'll try back into this. Then 1 minus root 2 is just root 2 over, now here, the 2, right, we need to keep as a part of our product. And then we have root 2 times root 2, which is what? 2, hey, sorry, my 2 is a bit far extensive here. So this is basically 2 times 2, like that. Right, because we have a 2, and then root 2 times root 2 is just 2. right? The square root cancels that out. So the final answer here is root 6 plus root 2 over 4. And I think that is what it said on the calculator. Let me type it in. Is that correct? Let's see quickly. Cos 15. Yes, root 6 plus root 2 over 4. Well, guys, if you go from this to this, you're going to lose marks. And if you've got try and skip steps, if the question says without using the calculator, you do actually have to show the steps. You could have gone from this line to that line, that would have been fine. Okay, so you could have skipped the step where you're writing them as two separate fractions, but you do have to show how you are rationalizing the denominator if you are asked to. Right, but this, you only do, right on the side, only if asked to write answer with a rational denominator. Okay, that example kind of took a bit of a light on its own. All right, what I actually wanted you to just practice is this. This compound angle identity. Okay, what was this first step? But anyway, we revised a lot of stuff now. Okay, so guys, that is the first compound angle identity. Now, what I want you to notice is that, because it's going to become clear now, when we have a minus in this bracket, there's a plus in the expansion. All right, so let's just draw a little arrow from the minus to the plus. All right, because that is going to happen when you're doing the other one. When we have cos x plus y, we're going to have a minus in the expansion. Okay, so for the cos ones, the signs are always different. So that was the first one. The second one is cos of x plus y is equal to cos x times cos y minus sine x times sine y. So we have the exact same terms in these two expansions. The only thing that's different is the sign. Okay, so if you have cos with an x plus y, so two angles are being added together, then in your expansion there's going to be a minus. But we do have to know almost like a little proof for this, a derivation of. I'm not going to do it now because I don't want to confuse you. I first want us to actually practice these before we start putting it. All right, so that is the second one, and then there are two sine ones. All right, so we have a sine x minus y. On the sine one is different. We're looking at the cos ones, both of them have cos, sine, right, in the expansion. Do we see that? Cos, there's cos, and then sine, and we have a different sign than in the brackets. All right, for the sine one, it's different. So we're going to have sine of the first bracket times, sorry, of the first angle times cos of the second angle. Right, so it's not cos or sine, it's actually sine cos. All right, so the first term is sine of the first angle times cos of the second angle. And for these ones, we're actually going to have the same sign. So there's a minus in the bracket, there's a minus in the expansion. And then we're going to have cos of the first angle times sine of the second angle. Okay, so here we have the same sign. So what I'm going to do now is I'm actually going to circle these two signs because they are the same. For the sine compound angle identity, for the minus in the brackets, there is going to be a minus in expansion. But also you mix the sine and cos together. All right, so it's sine cos and then cos sine. Same thing for the plus. So if we have sine of x plus y, we're going to have sine cos, so sine x times cos y, sine of the first angle times cos of the second angle, plus cos of the first angle times sine of the second. And as yes, you do get a formula sheet, these identities will be on the formula sheet. But it's good if you are able to recognize them without having to rely on the formula. Okay, so I want you guys obviously to practice when you are doing these in class for the first bit. You can obviously look at the identities, but it is good if you actually know them by heart because then you can do it identify them. Okay, let's do some more examples. I did say I was going to do more proving identities. Okay, let's do that because that is what I said we were going to do. Okay, let's just do some more examples. Sharing at least do it software like audio. All right, prove that sine 90 plus theta equal to cos theta. Guys, isn't that a reduction here that you know? Okay, sine of 90 plus theta, you would take this out. You would just ask to simplify this, right? You would say, what quadrant is 90 plus theta? Quadrant 2. What is sine of the second quadrant? Positive, but because it's a 90, I must change sine to cos. All right, so we know this already, but now they're asking us to prove it. All right, so now we can actually use compound angle identities to prove this because isn't this a compound angle? 90 plus theta. All right, so let's do that. The left hand side is equal to, I'm just going to rewrite it, sine of 90 plus theta. And now let's see, it is this up there. All right, it's that compound angle identity. So we're going to say sine of the first angle times cos of the second angle. So sine of 90 times cos of theta. Right? If there's a plus in the brackets, there's going to be a plus in the expansion. So plus. Then we say cos of the first angle times sine of the second angle. So cos of 90 times sine of theta. Now guys, from here, when it's 90 degrees, we need to think of the graphs, right? So let's just quickly remember what those graphs look like. The sine graph and the cos graph. Sine graph starts at 0. Then at 90 it goes up to 1. So sine 90 is 1. Again, so this is going to prove that question. I think right that they want to see that you know that sine 90 is 1. Remember, since at 90 degrees, you don't have to write that. You don't have to draw like a triangle or graph or anything on the side. You just kind of have to do it. So this is the proof that you know that sine 90 is 1. And then plus, let's think of the cos graph. The cos graph starts at 1, right? And then goes down to 0 at 90. So cos 90 is 0 times sine theta. So what does that make our whole second term equal to? 0. Hey, sine equal 1 times cos theta, which is just cos theta, which is what we have on the right hand side. Okay, any questions on that one, guys? I'm going to do one more. Give me a second, copy that down because I need to turn the page. Hold on. Okay. Guys, this whole thing is you having your phones on your desk just so that you can quickly reply to a message the second I stop talking is actually not on. I need your phone to be in your bags, out of sight because you keep getting distracted by them. And it's actually quite disrespectful as well. Like I have to wait for you guys to finish your phone conversation before I can continue with my class. So I do not want to see your phone, guys. I'm actually going to start time just taking them because it's crunch time now. We need to focus. But it's pretty great. And guys, at the moment, there are no compound angles there, right? In the brackets, actually. But if we look at what they are asking us to prove, I'm going to start by working on the left-hand side. Now, it's really easier to work from multiple terms to one term. If that makes sense, right? So we have two terms here. So I'm rather going to work with the two terms and then get that to one term, because we could possibly factorize, or we can get terms and add them as a factorial. It's easier to go from multiple terms to one term. All right, because you might be tempted to start working on the side. You could, it would just be easier from here. Now, if we're looking at what they gave us a 6a and a 4a. Now, obviously, I can't add these two things together. They are not like terms, right? Sine 6a and sine 4a, I can't add those together. So then we need to look at what we're trying to prove here on the right. There's a 5a, right? And there's also a 1a. So now we need to start thinking, okay, can I write these angles in terms of 5a and a? So how am I going to introduce a 5a and an a? That's what I need to get to. But there is no 5a here, there's no 1a. Yes. Yes. Alright, so guys, what I'm going to do here is 6a. I'm going to write that, just if you want to try. For that one. Yes. Okay, so 6a is going to be the same as 5a plus a. Right, so I can rewrite 6a as a compound angle, 5a plus a. Again, guys, just because I'm looking at what is on the right, somehow I need to introduce a 5a and an a. I'm going to write 6a as 5a plus a. Yes. So, not actually in this case, because if you wanted to do that, that would mean that sine 6a is the same as sine 4a times 2a. Or sine 4a times sine 2a, and it's not actually. Okay, yeah. So that's what it was asking now. Sine 6a is not the same as sine 4a times sine 2a, I suppose, is what you're thinking. Right, that's not the same. Yeah, okay, so we'll get to that now. So this 6a, we're going to rewrite as 5a plus a. And the sine 4a, we are going to rewrite as 5a minus a. So guys, just to come back to this whole factorizing thing, because it's a common in this conversation, I think you can only factorize, you can only take out, say if there was like a 2 sine 4a, then you could take out the sine 4a as a common factor. But you can't separate like the angle in order to take out something. Right, you can't really mess with the angle. The only thing that we can do is we can rewrite the angle just as a sum or as a difference. Here. Okay, so now we need to expand both of these, right? So sine 5a plus a is going to be sine 5a times cos a. Right, sine of the first angle times cos of the second, plus, remember for the sine expansion, we keep the same sign as in the brackets. For the second term, we're going to say cos of the first angle, so cos of 5a, times sine of the second angle. Now I'm just going to underline this so you don't get confused. This sine 5a plus a is this expansion. Right, that's just using the compound angle identity that we wrote on the previous page. So we still have to do the second one. Okay, so this one term turns into two terms. So now plus for the second one, I'm also going to put this in on this page. Now we have sine 5a minus a. It's again a sine expansion. So we're going to say sine of the first angle times cos of the second angle. Right? Because there's a minus in the brackets, we put a minus in the expansion. Then we're going to say cos of the first angle, so cos of 5a times sine of the second angle. So now this is equal to this. So it looks like we've complicated things a lot, right? Because we have very long things happening there. So if you actually look at those four terms that you have now, you should start noticing that they are like terms. right? The first term, there's just an equals in front, all right? The first term is sine 5a cos a. Is there another term with a sine 5a and a cos a? That one there, right? So these two are like terms, all right? What is sine 5a cos a plus sine 5a cos a? 2 sine 5a cos a, right? It's like an xy plus xy is 2xy. Okay, so this is going to be 2 sine 5a cos a. When I add those two terms together, right? Those are like terms. Now let's look at the other terms that we have. Hopefully you can see that these ones are also like terms. Cos 5a sine a and negative cos 5a sine a. Okay, what is xy minus xy? 0, right? So cos 5a sine a minus cos 5a sine a is 0. So if it helps, you can just draw a little line through those two to show that those two effectively cancel each other out. Right, so the sum of those two, or the difference there, is just 0. So this is our final answer, guys. And is this what I was supposed to get on the right-hand side? Yes. Okay. But I did this example now so that you could see that it's not always very clear right from the start that you have to use these compound analyzers. Right, it is going to take some practice in actually recognizing when you need to use them and when you don't have to. All right, but if it's a case like this, where you are starting with a 6a and a 4a, but in what you have on the right-hand side, you don't have a 6a and a 4a, right? You have 5a and 1a, for example. Then you need to start thinking, how can I rewrite 6a and 4a so that they have these angles in it? Okay. Give you guys a few to practice on your own. So exercise 5.6. Those four. I will just write them out for you because they are on separate pages. So it's also just prove the identities, that's the instruction. You can start working on that now, that is due tomorrow, please. And guys, I just want to make sure that everyone got the message that your self-study is not due tomorrow, it's due next week, Tuesday. Yes, but if you finish it, you can bring it to me. I will keep it in a safe place. If it's maybe just something that you want to do and get done, then that's fine. Okay, that is 1A. You have to prove that. That is 1E. That's I, and then the last one. Okay, those are the four that you have to do, please. That we have actually done examples similar to all of them. There's just a little extra thing in C if we're looking at that 1/5 degree angle there, that you can just think of. But yeah, you have to do all of these without using calculators, right? That's very important. So you're proving on identity without the use of the calculator, but just have to practice. So we did a very similar one to we did cos 15, now we start 5/15. And then the others are similar to the other ones that we practiced. Okay, get going on that now, guys. You can listen to music if you want. You have 10 minutes, so you can finish the first one, maybe two. I just stop recording here.